here are all the problems that we're going to be doing in this video. So we're going to be filling out the table, we're going to be graphing them. I'll also have you do one as practice. And then there are going to be some application-based ones at the end. So feel free to skip around, but I recommend watching the whole thing because each problem builds on the previous one. Alright, let's begin. I want you to imagine a circle. Now imagine stretching that circle like this. You'd end up with an ellipse. You could have also stretched it vertically. So maybe you'd get something like this. Or you could have done it diagonally. But an ellipse is basically a stretched circle. Now, the center of an ellipse is here. So just say it's the center. And if we wanted to cut this ellipse in half, there'd be two ways of doing it. So this way and this way. But the longer one is what we call the major axis, and the shorter one is what we call the minor axis. So where would the major and minor axis be for this ellipse? This is the major axis, this is the minor axis. Okay, and if I start at the center and I move on the major axis, then once I get, so I start at the center, move on the major axis, once I get to the ellipse, I'm gonna be at a vertex. I could also have moved in the opposite direction, but on the same major axis, and that would put me at another vertex. Where would the vertices be for this ellipse? It'd be here and here. Vertex, vertex. Okay, so the vertices are on the major axis. The co-vertices, co-vertex, co-vertex. Co-vertices are on the minor axis. So where would the co-vertices be for this ellipse? They'd be here and here. Okay. Now the distance between the center and a vertex is A. The distance between the center and a co-vertex is B. So if this is A, how long is this? It's also going to be A. So that means how long is the major axis? How many A? 2A. How long is the minor axis? How many B? 2B. Okay. Now, what does the word foci mean? So I want you to go back to the circle. And circles are special because every point on the circle is equally distant to the center. The distance is the same. And the distance to the center is what we call the radius. Now with an ellipse, it's a little bit different. With an ellipse, we have foci. So this is one focus, and this is another focus. Foci is just plural for focus. But every point on this ellipse is special as well. On any ellipse is special because the sum of the distances to the foci is always going to be the same as the major axis length. So this plus this is equal to 2a. And it doesn't matter which point you start out with. So you could have started here. This plus this. So this length plus this length is also going to be 2a. You could have started here as well. These two lengths are going to add up to 2a as well. Okay. This length plus this length is also going to add up to 2a. I'll do one more. This length plus this length is the same length as the major axis. You could have also started at a vertex. So this length plus this length is also 2a. But the distance between the foci is 2c. All right, distance between foci is 2c. Okay. So basically this, to go from the center to a focus, how many c is that going to be? So this whole thing is 2c. That means I need to take half of it. So it's going to be just 1c. And this is also c. Okay. And to get c with an ellipse, the formula is c equals square root of a squared minus b squared. Now I want to talk about latus rectum. I'll just write it here. Latus rectum. So what's a latus rectum? A latus rectum is a line segment that is parallel to the minor axis, but it goes through a focus. So this would be a latus rectum. There's also another one in this ellipse. Where is it? So it has to go through a focus, and it has to be parallel with the minor axis. This is a latus rectum. Okay. And how long is this? Well, the formula is 2b squared over a. If I were to say that this ellipse had a focus here and here, where would the latus rectums be? It would be here and here. Latus rectum. Now, what does eccentricity mean? Eccentricity just means how much you stretched the initial circle by. So if you stretched the circle by a lot, you're going to get an eccentricity pretty close to 1. But if you barely stretched it at all, then you're going to get something closer to 0. But the formula for eccentricity is c over a, where c is the square root of a squared minus b squared. Okay, let's go do some problems. Here's the first problem. Okay, so where would the center be? The center is right here. But what are the coordinates? The coordinates are 0, 4. And they're 0, 4 because when I start at the origin, I don't need to move in the x direction. So that's why the x coordinate is 0. But I need to move in the y direction. I need to go up by 4 to get over here. Go up by 4, and that's why the y coordinate is 4. Okay. And the x coordinate of the center is what we call h. The y coordinate is what we call k. You'll need to remember this for later. Now, is this a vertex or is it a co-vertex? So the longer axis is the major axis. And with the major axis, you're going to go to a vertex. What's this called? Well, the shorter one is called the minor axis. And this is called a co-vertex. But how long is the major axis in terms of A? How many A? 2A. So if this whole thing is 2A, how long is this? This would just be half of 2A, so just A. But how many units long is A? How many units to the right do I need to move to go from the center to the vertex? 2 units. Okay, we have enough information to get started. So, what does it mean to write an equation in standard form? What would an equation for an ellipse even look like? So it's going to look like this. So either it looks like this, or it looks like this. This is what we call standard form. Which one do we use? Well, that's easy. So for A, we're moving horizontally. So that's in the x direction. So that means A has to go with x. So we go with this one. Okay, let's get started. So I'm going to start copying this. So x minus h. H was how much again? H is 0. Okay, over a squared. We don't have a squared yet, but we have a. How can we get a squared? What do we need to do to both sides of this equation? We need to square it. So to go from here to here, I had to multiply a by itself, which means to go from here to here, I need to multiply 2 by itself. What's 2 times 2? 4. A squared is 4. So what goes on the bottom here? I can change a squared to 4. Okay, now I want you to pause the video and copy my steps for this part. Well, not exactly copy, but kind of replicate it. Okay, what did you get? So it's going to be y minus k, and k is 4, over b squared. So how do we find b? So b is half of the minor axis. So how many units is this? Just 1 unit. That means b squared is 1 times 1, so just 1. So that means I can change this to 1. Okay, we can simplify this a little bit. X minus 0 is the same thing as x. So I just change this to x, keep the squared. And then dividing by 1 is the same thing as just keeping this. Like you don't have to write over 1. Yeah, this is the same as this. This is your answer. Okay, and here's some things that I'd like you to make a mental note of right now. Okay, so if I look at this equation here, if I take this number and multiply them by -1, so 0 times -1 is how much? 0. And -4 times -1 is how much? 4. So if I multiply these two numbers by -1, I'm going to get the center. Just make a mental note of that. Okay. What else? The larger of these two numbers is a squared. So a squared is equal to 4. The smaller of these two numbers is b squared. Just make a mental note. Why is a squared always the larger? Because a is always going to be longer than b. Why is a longer than b? You tell me. A is longer than b because the major axis, so okay, I'll write it like this. A is always longer than b because the major axis length is always going to be greater than the minor axis length. How long is the major axis again? 2a. The minor axis is how long? 2b. So if I divide this inequality by 2, I'm going to get a is always longer than b. Since a is always longer than b, then that means a squared is always going to be greater than b squared. Because I can just square both sides of this inequality to get over here. So that's why. But just make a mental note that the larger of these two numbers is a squared and the smaller one is b squared. To find the center of an ellipse, take this number and multiply them by -1. So 4 times -1 is how much? -4, and -2 times -1 is 2. Since this is with x, I'm going to use that as my x-coordinate for the center. And since this is with y, I'm going to use that as my y-coordinate for the center. This is your answer. By the way, we call the x-coordinate h, and we call the y-coordinate k. Okay. How do we find the major and minor axis lengths? So you need to find 2a and 2b. So how do we find a? Well, a squared is the larger of these two numbers. So which of these two numbers is larger? It's this one. So a squared is the larger of those two numbers. So 25. Okay. So that means a is how much? What do we need to do to both sides of this equation to get over here? So to go from here to here, I need to take the square root of the left-hand side of this equation. So I'll draw an arrow. So that means to go from here to here, I also need to take the square root. What's the square root of 25? Square root of 25 is 5. So if a is 5, how much is 2 times a? Two times a is the same thing as 2 times, well, I can just change a to 5, and 2 times 5 is just 10. This is your answer. Now, I want you to repeat my steps to figure out the minor axis length, but this time, you're going to be using the smaller of these two numbers. So this one's smaller, that means b squared is 4. Okay, I'll give you a second to pause the video and replicate my steps. Okay, what did you get? You should have gotten that b is equal to the square root of 4, which is equal to 2. And 2b is equal to 2 times 2, which is just 4. This is your answer. How do we find the vertices? Well, since this is the larger of these two numbers, I'm only going to be changing the x-coordinate of the center to get the vertices. So the y-coordinate we keep the y-coordinate. And it's the same idea for the foci. With the co-vertices, it's the opposite. But remember, the reason why, okay, well, what is the reason why we're changing the x-coordinate again? It's because this number is larger than this number, and it's with x, so we change the x-coordinate. However, if this number was larger, then this would look very different. And I'll include another example where this number is actually larger than this one. But to find the vertices, are the vertices on the major or minor axis? They're on the major axis. How far away from the center do we need to move to get to the vertices? We need to move a units from the center. So move a units away from h. So to move a units away from h, we can add a and we can subtract a. So I'll just put a plus minus a here. How about with the co-vertices? Are the co-vertices on the major or minor axis? They're on the minor axis. How do we get to them? We need to move b units away from the center. So in this case, move b units away from k. Okay, and I'll just put a plus minus b here. How about with the foci? Are they on the major or minor axis? The foci are on the major axis. And this time, we're working with C. So add C to H and subtract C from H. Okay, let's go ahead and plug in H and A in order to get the vertices. So H is how much again? H is -4. What about A? Okay, so A is 5. All right, and what's -4 plus 5? -4 plus 5 is 1. Okay, so this is one vertex. Now I want you to pause the video and repeat my steps for this vertex. The only thing that changes is the minus sign here. Okay, what did you get? You should have gotten -4 minus 5, 2, and -4 minus 5 is just -9. So your other vertex is -9, 2. Okay, now I want you to pause the video and repeat my steps. Repeat what I did with the vertices, but this time with the co-vertices. Okay, what did you get? So this time, K is equal to 2 plus B. B is 2. Okay, so that means 2 plus 2 is 4. And then here it's -4, 2 minus 2. So that gives me -4, 0. Okay. How about with the foci? What's the formula for C? With an ellipse, only with ellipses, C is equal to the square root of a squared minus b squared. With hyperbolas, it's different. Okay. So, to figure out C, we need a squared and b squared. Do we already know what those are? So a squared is which one of these? It's the larger one. So a squared is 25. B squared is the smaller one. So what do we change this to? 25. And what does this change to? That one changes to 4. 25 minus 4 is how much? $21. Okay, and can we simplify this radical? No, we cannot, because the only perfect square that evenly goes into 21 is 1. Okay, so C is the square root of 21, so we can go ahead and plug that into here. So I'll give you a second to pause the video and do that. Change H to what it's equal to and change C to root 21. Do it with both points. Okay, what did you get? You should have gotten -4 plus root 21, 2. Okay, so that's 1. And then the other one is -4 minus root 21, 2. Okay. Now the formula for lattice rectum length for ellipse and hyperbola is 2b squared over a. I'll give you a second to pause the video and plug in the values for this formula. Okay, you should have gotten b squared is 4, so 2 times 4 over a. If you forget what a is, well, a is associated with the major axis length, so just look over there. A is 5. 2 times 4 is 8. And can we simplify this fraction? Like, is there anything we can cancel here? Nope. This is your answer. Okay, and to find the eccentricity, use the formula c over a. I'll give you a second to pause the video and do that. Plug in c and a into here. Okay, so c is root 21. And a, if you forget a, just go back to the major axis length and look for it. Is there anything we can cancel here? Nope. Okay, so this is your answer. To graph the ellipse, I've copied the center, vertices, co-vertices, and foci. So let's go ahead and start by graphing the center. So where would negative 4, 2 go? So negative 4, I need to go left by 4, and then I need to go up by 2. So that'll land me about here. Let's go ahead and graph the vertices as well. Where would 1, 2 go? So I have to go right by 1, up by 2. How about negative 9, 2? Where would that be? So go left by 9, up by 2. Cool. How about the co-vertices? So negative 4, 4, and then negative 4, 0. So don't go up. Okay, and then we're just going to connect the dots. Okay. And that's your ellipse. But we also need to graph the foci. And you can use a calculator to get an estimate of this number. But this is going to be approximately, it's going to be about 0.5. Okay. So this is about 0.52. So like right here, so 0.5 and then 2. And this one is about negative 8.5, 2. So it would be like right here. So those are your foci. And that's it. I want you to do this problem as practice. And your hint is that you can change x to x plus 0. All right, pause the video and give it a shot. Okay, what did you get? I'm gonna speed run this. Okay, so the center, that's gonna be this times negative 1, this times negative 1. Major axis length, 2a, this one's 2b. Okay, and then a squared is the larger of these two numbers, so 49. That means a is equal to the square root of 49, which is 7. So 2a is equal to 2 times 7, which is 14. And we're just going to copy the steps for minor axis. But b squared, we're using b squared, so the smaller of these two. Okay, so that means 2b is equal to 2 times 6, 12. This is your answer. Now, to find the vertices, co-vertices, and foci, you need to be thinking about A, B, and C. And since this is the larger of these two numbers, I'm only going to be changing y, the y coordinate of the center for the vertices and foci. For the co-vertices, it's the opposite. Okay, and all right, so this is h. I'll just write h and k here. And so what goes here? It's going to be k plus a. So 3 plus 7 is just 10. And then this one's 3 minus 7, k minus a. So 3 minus 7, that is negative 4. Okay. What goes here? So h plus b, so 0 plus 6 is 6, and then 0 minus 6, that's negative 6. And then to find c, you need to use this formula. And a squared is the larger of these two, so 49. B squared is the smaller of these two. 49 minus 36, that's 13. Okay, so k plus c, so 3 plus root 13, and then k minus c. And to find the lattice rectum length, use 2b squared over a. So 2 times b squared is the smaller of these two, and then a is 7. 2 times 36, 72. Can't simplify, this is your answer. Okay. C is root 13, A is 7. Okay. Okay, and here are the answers for graphing it. So you'll notice that the center, I put it here. The vertices are going to be 0, 10 are here, and 0, negative 4 is here. And co-vertices, so 6, 3, negative 6, 3. And the foci, I used a calculator to get that this is approximately 6.6. And this one's approximately negative 0.6. Okay, so to graph this, it's 0, and then approximately 6.6, and then 0, approximately negative 0.6. Okay, here's an application-based problem. I'll give you a second to read it. Okay, so it's asking for the distance between the foci. What's the formula for that? The formula for the distance between the foci is 2c. Okay. And what other information did they give us? So they gave us information about the vertices. And when you see vertices, think about A. When you see co-vertices, think about B. Okay. If you have information about A and B, can you figure out C? Well, yes, because C is equal to the square root of A squared minus B squared. So if you know A and B, you can get A squared and B squared, plug them into this formula, and get C. And if you can get C, well, you can just double your answer to get the distance between the foci. So we really need to be looking for A and B here. I'm going to graph this ellipse to get a better understanding of what it looks like. So let's go ahead and graph 2, 0 and 2, 8. So if we're graphing 2, 8, I think this graph needs to go up to 10, just to be able to include the 8. And then we'll count by 2s. Okay, where does 2, 0 go on here? So we go right by 2 and up by 0. So we're just going to land here. Where would we land at for 2, 8? So go right by 2 and up by 8. All right, so those are the vertices. What about the co-vertices? So -1, 4, -1, 4. And where does the other co-vertex go? So go right by 5, up 4. Okay. And I'm just going to draw out the ellipse. Now the vertices, are they on the major or minor axis? So these are the vertices 2, 0 and 2, 8. And vertices are always, they are always on the major axis. The co-vertices are always on the minor axis. Okay, so this is the major axis length. How long is the major axis length in terms of A? So to go from the center to the ellipse, how far do I need to move? I need to move A units. So in total, the whole major axis length is how many A? So that's why the major axis length is 2A. For the same idea, or for the same reasons, how long will the minor axis be? B. But we can figure out how long this is. How long is this? I'm going from 0 all the way up until 8. So how long is this? So the major axis length is 8. How long is the minor axis length? So we're at -1, 4 and 5, 4. So to go from -1 to 5, how many units do I need to move? So you can just do 5 minus -1, which is just 6. That's awesome. So now we can figure out A and B. How much are A and B going to be equal to? So A is going to be 4 because I divide both sides of this equation by 2. And B is going to be 3 for the same reason. Okay, well if A is equal to 4 and B is equal to 3, then we just need to figure out A squared and B squared. A squared and B squared to get our desired distance. So how do we do that? So to get A squared, I can square both sides of this equation. So if I square this side and get a squared, I need to square this. What's 4 squared? What's 4 times 4? 4 times 4 is 16. How much is b squared going to be equal to? B squared is going to be equal to 3 times 3. 3 squared, 3 times 3, that's 9. Okay, so to get our desired distance, we can change this to what we know it is now. So let's go ahead and do that. And this becomes how much? (16 minus 9 is how much? Can we simplify this radical? Nope, we cannot. So this is your answer. Okay, last one. So we're given the center, a co-vertex, the eccentricity, and they want us to write the equation in standard form. So to write an equation in standard form, what do you need? You need to know hk. Well, they gave us the center. So h is -5 and k is 5. What else do you need? You also need to know a squared and b squared. So let's see if we can get a squared and b squared from the other information that they gave us. Okay, so they gave us the co-vertex is -2, 5. When we see co-vertex, should we think about a or b? We need to think about b. The distance between the center and a co-vertex is b. So b is equal to how much? What's the distance between this and this? So to get from here to here, I just need to move right by 3. Another way you can get this is just by doing -2 minus -5. But since b is 3, we can pretty easily figure out b squared. How do we do that? Square both sides of this equation. So 3 squared is how much? 9. Okay, so all that we have left to find out is a squared. Let's see if we can make use of the eccentricity. So what's the formula for eccentricity again? The formula for eccentricity is c over a, and that's equal to √15/4. Okay. What's the formula for c? The formula for c is the square root of a squared minus b squared. Okay, so I just changed c in this fraction to square root of a squared minus b squared. And b squared was how much again? 9. So let's just change this to 9. Okay. Okay, I like where this is going because we have one equation and one unknown. That unknown is a. So how do we solve this? Well, I don't like working with fractions. So let's multiply both sides of this equation by this times this. So by 4a. This is what we call clearing the denominators. So what does this left-hand side turn into? Well, we can cross out the 4's, and we're left with a times root 15. What happens to the right-hand side? So this turns into 4 root a squared minus 9. Okay, how should we proceed here? Well, I don't like radicals, so let's get rid of those as well. How do we get rid of radicals? We need to square both sides of this equation. Okay, so what does the left-hand side become? So it becomes a squared. A squared times root 15 squared. What's root 15 squared? So the square root cancels out when you square it, when you raise it to the power of 2. So this just turns into 15. How about here? What's 4 squared? 16. And then the radical goes away because of the square here. So it's times a squared minus 9. How should we proceed here? Okay, so I'm going to get rid of the parentheses. I can rewrite this as 15a squared. Okay, equals 16 times a squared. And then 16 times negative 9. So negative 144. Okay, and what should we do next here? We need to combine the a squares. Combine like terms. So I'm going to subtract 15a squared from both sides of the equation. How do we solve this equation? Well, we need to get a by itself, but before that happens, we need to get... Oh wait, we don't need to get a by itself, because we're only looking for a squared. Yeah, let's just get a squared by itself. So add 144 to both sides of the equation, and a squared is 144. Okay, so this is all we need to write our equation in standard form. So how do we do that? Well, if you remember with our equations, there were 2 actually. Which one should we use? Well, to get from the center to the co-vertex, did we have to move horizontally or vertically? So we have to change the x-coordinate, and x means move horizontally. So, yeah, so since we're changing the x-coordinate to get to the co-vertex, that means b squared would have to go with x. Okay, so we're going to be using this one then. So x minus h, which is negative 5. So x minus negative 5, that's the same thing as x plus 5 squared over b squared. So 9 plus y minus k, so 5 squared over a squared. So 144. This is your answer.